Welcome to today's deep dive. We are really thrilled you could join us today because the journey we are taking is absolutely massive in scale.
It really is. I'm very excited to get into this one.
Yeah, we are mapping out a 2 million year timeline to understand exactly how humans came to spread across the entire globe. And right out of the gate, I want to challenge a common assumption you might have.
Right. The idea that this is just our story.
Exactly. When we think of incredible feats like global migration, island hopping,
Hmm.
using complex tools, we almost always assume that is strictly a Homo sapiens achievement. We tend to think of it as our exclusive story. But the history we're digging into today completely shatters that idea.
It does. These unbelievable feats weren't just done by our kind of humans.
No.
And to understand how these other, much earlier human species pulled this off, we have to establish the fundamental engine driving this entire deep dive. It all comes down to the Earth's climate. For the past 2.6 million years, an era geologists call the Pleistocene glaciations, the Earth's climate has been in a constant state of oscillation. It's this profound, rhythmic cycle between deep, freezing ice ages and warmer interglacial periods.
And the mechanics of that are what absolutely blow my mind. During those deep ice ages, huge volumes of the Earth's water become locked up in massive continental ice caps.
Exactly. The water freezes and stays on land.
Right, and when that water gets locked in the ice, it obviously isn't in the ocean anymore. So global sea levels drop drastically. We're talking about oceans sitting often 40 to 60 meters lower. That is roughly the height of an 18-story building.
Or even more. In some periods, sea levels were up to 100 or 125 meters lower than they do today.
125 meters.
Yes.
For a visual for you listening, that means the global ocean surface was sitting lower than the torch on the Statue of Liberty, including its pedestal.
That is a profound drop. And it fundamentally redrew the map of the world for early hominins. Shallow seas completely dried up, turning into vast, walkable plains.
They just became dry land.
Exactly. The coastline stretched far outward, meaning what we consider separate continents and isolated island chains today were entirely connected.
Okay, let's unpack this, because these periods of extremely low sea levels created massive land bridges, resulting in 4 major lost land masses from our source material.
Right.
You've got Sundaland, Sahul, Doggerland, and Beringia.
Right.
But these weren't just narrow little land bridges you could run across in an afternoon, were they?
Not at all. These were massive continental scale environments. Let's take Sundaland, for example.
Okay.
This was the combined continental shelf of Southeast Asia. When the oceans dropped, it linked mainland Asia all the way down to Java, Borneo, and Sumatra.
And Java wasn't the dense tropical island environment we picture today, right?
No.
It was a sprawling, open savanna absolutely packed with Ice Age megafauna.
Yes, exactly. Then you had Sahul, which was an immense, continuous landmass joining Australia with New Guinea and Tasmania. Over in northern Europe, Doggerland bridged continental Europe straight across to Scandinavia and England.
You could have essentially walked from modern-day London to Norway.
Without getting your feet wet?
That is wild.
Yeah.
And then there's Beringia, which is the one people usually hear about in school. That was the 1,000-kilometer-wide tundra plain connecting Siberia to Alaska.
Which is an enormous amount of space.
Yeah, that is a stretch of land roughly the length of Florida and Georgia combined. So we have this completely different Earth.
Yeah.
How did early humans like Homo erectus navigate a world like this?
Well, around 1.8 million years ago, these vast connected plains allowed Homo erectus to simply walk out of Africa.
They just walked.
They just walked. They
Yeah.
moved through the Near East and trekked all the way into Indonesia. We actually have fossils at Java's Sanjaran site dating back that far. They didn't need to invent boats. They just followed the migrating animals and the shifting savannas. But the crucial thing to remember is that these climate shifts were cyclical. Initially, they happened in 41,000-year cycles.
Oh.
And around 800,000 years ago, the rhythm shifted to 100,000-year cycles.
So it acted almost like a massive planetary pump. A place like Sundaland would emerge, early humans would walk across it, and then the climate would warm up again. The ice melts, the sea rises, and Sundaland floods.
Precisely. Those groups of Homo erectus would suddenly find themselves completely isolated on islands. Then, tens of thousands of years later, the sea would drop and they'd be reconnected to the mainland or to other islands.
It's like a trapdoor closing and opening over and over.
Exactly. And this relentless cycle of isolating and reconnecting populations forced rapid adaptation. It fundamentally shaped human endurance for hundreds of thousands of years.
It's incredible to picture. But walking across dry land only gets you so far. Which brings us to a massive mystery. By about 1.2 to 1 million years ago, Homo erectus, or their close relatives, were somehow occupying islands that were never connected to the mainland.
Right, even at the lowest sea stands.
Yeah, even when the Statue of Liberty's worth of water was locked up in ice, these islands were still completely surrounded by deep ocean.
You're referring to the Wallace Line?
Yes.
This is a deep water ocean trench in Indonesia that remained a formidable, seemingly impassable barrier even at the absolute lowest sea levels. Yet early humans somehow crossed it. They reached Flores, which later became famous for the fossils of the hobbit humans, Homo floresiensis.
And they didn't just stop there. They also reached Luzon in the Philippines. I know there's a massive archaeological find there that completely rewrites the timeline. What exactly did researchers pull out of the ground on Luzon?
Archaeologists uncovered a butchered rhinoceros skeleton surrounded by stone tools.
The butchered rhino.
Yes, and the dating on that site is astonishing. It is 709,000 years old. It proves archaic humans were there. And much later, that same island became home to another distinct dwarf species, Homo luzonensis, around 67,000 years ago.
Wait, so how did an archaic human species cross a deep water ocean trench over 1 million years ago? They couldn't walk. So what are the theories here?
This raises an important question that paleoanthropologists constantly debate. Did they do it on purpose or by accident?
Look.
The first major theory is the vegetation mat hypothesis. During severe coastal floods, massive tsunamis, or powerful typhoons, huge chunks of riverbanks or mangrove swamps get physically torn away and swept out to sea.
Like floating islands.
Exactly. These buoyant, tangled islands of wood and plants can stay afloat for weeks. We actually see this happen today with modern hurricanes carrying small animals between islands. So it is plausible that a small group of early humans was simply swept away by a storm, clung to a mat of debris, and miraculously washed ashore on a new island.
I hear the logic of the vegetation mats. But surfing a mangrove swamp across an ocean trench sounds like a massive stretch to me. It sounds almost too lucky, especially if it resulted in sustainable populations across multiple islands. I have to admit, I heavily lean into the other theory, the idea that Homo erectus purposely built simple rafts.
It is a compelling alternative.
Right. When you look at Homo erectus, you see they were already doing distinctly human things. They utilized tools, they controlled fire, they adapted to dozens of different environments. Is it really that absurd to think they could look at floating logs, maybe lash a few together with vines, and intentionally set out?
It's not absurd at all, though it requires a higher level of cognitive planning than many traditionally credit to Homo erectus. But if we connect this to the bigger picture, whether it was accidental drifting or intentional rafting, we have to dispel the modern myth of what these crossings looked like.
What do you mean?
They were not blindly voyaging into a terrifying open ocean with no destination in sight. The physical geography of Oceania is the key. These island chains are highly mountainous, with peaks ranging from 300 to 1,700 meters high.
So they weren't just staring into an endless blue void hoping for the best.
Not at all. Because of those towering peaks, the distance between the islands allowed for what we call line-of-sight navigation. If you stand on the shore of one island, you can look across the water and physically see the peak of the next island on the horizon. The promise of land was always visible. You know exactly where you are trying to go.
That makes a massive difference in how we picture this. And that line-of-sight concept doesn't just apply to Southeast Asia. It perfectly explains a mystery halfway across the world in the Mediterranean.
Yes, the Crete anomaly.
Exactly. About 130,000 years ago, Neanderthals, or possibly other archaic humans, made sea voyages to the Greek island of Crete. And Crete is an island that has been completely isolated for 5 million years. There was never a land bridge.
And we know archaic humans made it there because archaeologists found Acheulean stone tools scattered across Crete.
Just to clarify for anyone who isn't an archaeology buff, why do Acheulean tools specifically prove it wasn't modern Homo sapiens?
Acheulean tools are a very specific style of heavy, teardrop-shaped hand axes and cleavers. They are the signature million-year-old toolkit of early human ancestors, like Homo erectus and Neanderthals. Modern Homo sapiens had moved on to different, often more refined tool technologies by the time they would have been in the region. Finding Acheulean axes on Crete is a smoking gun for archaic humans making a sea crossing.
And just like in Indonesia, they used the geography to their advantage. They didn't just sail blindly south.
Right. It was a deliberate stepping stone journey. The most likely route started from the Peloponnese mainland. From there, it was about a 6-mile crossing to the island of Kythera, then a 20-mile crossing to Antikythera, and finally a 19-mile stretch across the sea to Crete.
We were island hopping.
Yes. And just like those Indonesian islands, these Mediterranean islands have high elevations. From the shore of one, the horizon stretches far enough that you can see the next landmass waiting for you.
But there is a really dark, profoundly human twist to this that we have to acknowledge.
The risk involved.
Yeah. The very first people to try this crossing probably didn't master the ocean currents right away. They were venturing out on simple experimental craft. And the families waiting back home on the mainland, well, they wouldn't know what happened. When their friends or loved ones paddled over the horizon and didn't return, did they drown at sea? Or did they find a lush paradise island and just decide to stay? That kind of emotional way to migration, the fear of the unknown, is something that stretches back hundreds of thousands of years.
It's a haunting reality, and it grounds this ancient abstract history in a very relatable human experience. And speaking of the Mediterranean, there is an incredibly tangible piece of history found at Epidemic Cave in southern Greece. This is a seaside cave complex situated on a rugged cliff face. Today, you can only access it by boat. Deep inside this cave, researchers found two distinct fossilized skull fragments.
This is the part that gave me chills.
It's remarkable. One is a Homo sapiens skull dated to about 210,000 years ago. The other is a Neanderthal skull fragment dated to about 170,000 years ago.
Found perfectly preserved in the exact same cave.
Exactly. Now, we already know from modern genetic evidence that these groups intermingled. Modern humans of West Eurasian descent carry about 2% Neanderthal DNA, which proves our species met, interacted, and had offspring.
Right.
But finding the physical remains of both Homo sapiens and Neanderthals occupying the exact same physical space, even separated by thousands of years, makes that genetic history deeply tangible. They were sheltering in the same caves, looking out over the same oceans.
It really hammers home that we shared this planet. But as we move forward in the timeline, we do eventually reach the Great Migration of Homo sapiens. This is the wave of movement that eventually led to modern populations covering the globe today. How did that push out of Africa actually play out?
Around 70,000 years ago, Homo sapiens began a major, sustained expansion out of Africa. They likely crossed via the Bab el-Mandeb Strait at the southern end of the Red Sea, or they took a northern land route through the Sinai Peninsula. And just like the archaic humans before them, they were heavily aided by the shifting climate.
Right, because the deserts weren't always deserts.
Exactly. Around 50,000 years ago, brief green corridors opened up in what is now the incredibly harsh Arabian Desert. Increased monsoonal rainfall created lush, hospitable environments with massive freshwater lakes and dense vegetation. It allowed our ancestors to move rapidly across regions that would be entirely deadly to cross on foot today.
And their movement across the globe was staggeringly fast. By 50,000 to 40,000 years ago, they pulled off the colonization of Sahel, that massive connected landmass of Australia and New Guinea. And reaching Sahel wasn't just walking across a green corridor. This required crossing substantial stretches of open water.
What's fascinating here is what the genetic evidence tells us about the scale of that maritime migration. When scientists study modern Australian Aboriginal genetics, they see absolutely no sign of a severe genetic bottleneck.
A bottleneck meaning just a tiny handful of survivors,
Yeah.
right? Like one lucky raft washing ashore and populating an entire continent.
Exactly. If just a dozen people populated a continent, their descendants would have very little genetic diversity. But the genetics of indigenous Australians show a robust, incredibly diverse lineage from the very beginning. Mathematical models imply that successfully reaching and populating Australia required a founding population of anywhere from 100 to 2,000 people.
Wow, up to 2,000 people.
Yes. You do not get those numbers by accident. That requires massive, continuous waves of intentional, highly confident seafaring across those deep water straits.
They weren't just drifting, they were executing coordinated migrations. But as these human populations were spreading out and mastering their environments, the planet was preparing to flip the script on them again. Humans eventually pushed all the way up into northeastern Asia. They crossed that massive Beringian land bridge we talked about earlier. There was actually a period called the Beringian Standstill, where humans lived in Beringia for a few millennia, blocked by massive ice sheets, before finally moving south into the Americas around 16,000 to 14,000 years ago.
Right.
But then, the Ice Age ends, the massive glaciers melt, millions of cubic gallons of water return to the oceans, and it brings a catastrophic end to these ancient coastal worlds.
It was a brutal transition. Around 8,200 years ago, a massive underwater landslide occurred off the coast of Norway, an event known as the Storegga Slide. It displaced so much earth beneath the ocean that it triggered a colossal, devastating tsunami across the North Sea.
And this wasn't just a wave hitting a beach. This fundamentally altered the map of Europe.
It wiped out the last remaining low-lying habitable parts of Doggerland in what was likely a single generation. It was an apocalyptic event for the hunter-gatherers living there. It definitively severed the land connection, turning Britain into an isolated island. And these catastrophic, rapid sea level rises, tsunamis, flooding entire landscapes, coastal camps being swallowed by the rising tide are very likely the ancient birth of global flood myths.
Like Atlantis.
Exactly. It's the origin of stories like the sinking of Atlantis, passed down through millennia of oral tradition.
It's completely chilling to think about entire worlds, entire hunting grounds, and generations of settlements just vanishing beneath the waves. But humanity's greatest trait is adaptation. And here's where it gets really interesting. Because if we jump forward to just 5,000 to 3,000 years ago, we meet the absolute ultimate engineers of the ocean, the Austronesian and Polynesian peoples. They did something completely unprecedented in the history we've discussed today. They threw out the line-of-sight playbook entirely, didn't they?
They did. They mastered true deep-sea, open ocean voyaging. No safety net of a visible mountain peak on the horizon, just the endless blue of the Pacific. Using incredibly advanced ocean-going double-hulled canoes and a masterful system of celestial navigation reading the stars, the flight paths of birds, and the invisible swell patterns of the water, they sailed out of Southeast Asia. They colonized the most remote islands on Earth, places like Hawaii, New Zealand, and Easter Island.
It's arguably the greatest navigational achievement in human history, but they didn't just stop at the islands. There's a genetic footprint that points to them going even further, right?
Yes, around 1200 CE, which in the grand scheme of our timeline is just 800 years ago, Polynesian explorers sailed eastward from their islands all the way to the coast of South America.
Unbelievable.
They interacted with Native American populations there, and then they successfully sailed back into the Pacific. We know this for a fact because modern genetic studies show traces of Native American DNA in certain eastern Polynesian populations. But the exchange wasn't just genetic. They brought something back with them that completely transformed their agriculture.
The sweet potato. I have to say, I completely geeked out over this detail. We think of a potato as just a basic vegetable, but the sweet potato is basically ancient, bioengineered sci-fi tech. Native Americans in places like Peru and Ecuador spent roughly 5,000 years cultivating what was originally a wild, toxic plant into an absolute superfood.
It really is.
It is the ultimate survival ration. You can literally just throw a sweet potato in the dirt, completely ignore it, and it thrives. It vines out, you can eat the leaves, you can eat the stems, and it yields these incredibly calorie-dense tubers that won't spoil for months, making them the perfect food for long ocean voyages.
It is the perfect encapsulation of human ingenuity. When those Polynesian canoes arrived on the shores of South America, it was the ultimate meeting of two incredibly different forms of human engineering. You have the highest tech open ocean vessels and navigational systems the world had ever seen, suddenly coming face to face with the absolute highest tech agricultural bioengineering in the form of the sweet potato. Two completely different expressions of mastery over the natural world, connecting across thousands of miles of uncharted ocean.
So what does this all mean for you listening today? I think the core message here is that migration, relentless adaptation, and survival aren't just modern human traits. For 2 million years, multiple species of humans have been adapting, building, navigating, and moving. And they did it all to the rhythmic beating of the Earth's shifting ice and sea levels. We didn't conquer the globe in spite of the climate. Our evolution was driven by it.
It serves as an incredibly powerful reminder that the map of the Earth you know today, with the coastlines exactly where they are drawn in your atlas, is just a temporary snapshot. It hasn't always looked like this, and as the climate continues to change, it certainly won't always look like this in the future.
And to leave you with a final thought, we've spent this entire deep dive talking about how much lower the oceans used to be, and how that allowed humans to walk across the globe. But there's a detail we haven't mentioned yet. During the warm interglacial period, roughly 125,000 years ago, right before Homo sapiens made their big push out of Africa, global sea levels were actually 6 to 9 meters higher than they are today.
It makes you wonder, as we watch our own coastlines begin to shift today, what ancient human footprints, what coastal settlements, and what chapters of our own story are currently sitting far beneath the waves, waiting to be discovered.
Something incredible to think about. Thank you so much for joining us on this deep dive. We'll catch you next time.